Good afternoon, ladies and gentlemen. Welcome to TechEd webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Cloud Computing Series, Session 11, the need for a dynamic multi-layered security model for cloud computing. Our guest speaker today is Ms. Triveni, TK, Professor, Cloud Trainer, Cloud and Security Consultant. Triveni TK is a freelance cloud computing trainer for EXI and CompTIA Cloud School Cloud Security Certification. She holds doctorate in Business Studies, MTech, BE, and is currently pursuing PhD on Cloud Security. She works as a part-time professor in Manipal University and is guiding 4 projects on cloud computing. She has published award-winning research papers on cloud and cloud security. With more than 12 years' experience in teaching, consulting, and cloud corporate training for reputed organizations, she offers well-earned qualifications as a trainer, consultant, visionary, and motivator of strategies that have exceeded expectations. She is an expert on cloud security with proven cross-functional qualifications that span management, technology, and engineering. So without further delay, I introduce you all to our guest speaker. Over to you, Ms. Triveni.
Thank you. A very good afternoon to all participants. Myself Triveni, cloud computing trainer, professor and consultant. I'm here to discuss the need for a dynamic multi-layered security model for cloud computing. So without any further ado, let's go about discussing why do we need this. Now, we all know what cloud computing offers. TechGeek so far has arranged for many interesting and enlightening series on cloud computing, and we've all understood that cloud offers huge flexibility. It is elastic in nature. It is convenient, on demand, easier to access, and of course, the main profit would be the cost along with the agility. But, and this is a very big but, unless we provide the assurance that employees of the provider themselves would be unable to take off your personal data, and the provider servers themselves are very secure, and any hacker would not be able to target your data by contacting the provider as you. Unless we provide these assurances, trusting the cloud will be difficult, and hence using these exciting offers of cloud computing would be difficult.
Mr. Triveni, sorry for interrupting, but can we see the slides?
Is the cloud safe?
Full screen mode. Can you share it in full screen mode, please?
Pardon me?
Can you just share it in full screen mode? I mean, your slides.
You want me to enlarge
Exactly.
like this?
Yeah, that's
okay,
good.
Sure.
Okay.
Okay. So now, is the cloud really safe, or do we have any problems with the cloud as such? As researchers have found, there are massive security flaws in cloud architecture. Many big cloud service providers like AWS, they found vulnerabilities within their cloud services. They were found and fixed, but as they have shown, other providers are also susceptible to these kind of security flaws. The general opinion is this will not happen to us unless, of course, someday it happens to us. Recent breaches, they have shown that anyone could be a victim of attack on cloud security, especially cloud providers. They are attractive targets for attackers since liability cannot be outsourced. When you take cloud services from a provider, you cannot put the liability of your services on your provider. So yes, it can happen to us. It can happen to anyone. Let us see the most important cloud security risks as identified by Cloud Security Alliance, which is a non-profit organization working on cloud security. Data loss or leakage is the first and foremost threat. On a day-to-day basis, we are losing a lot of data. Confidentiality of data is being compromised in a huge way. The very fact that cloud is a multi-tenant model provides a great risk on shared technology vulnerabilities. The very fact that we are sharing our data, our resources with many providers all around the world is itself a huge security risk. And in spite of our devices being secure, in spite of our operating systems being secure, the applications that we download on a day-to-day basis might be insecure. So these again provide security risks when downloaded from the cloud. So yes, if the users of cloud are not careful, there might be a lot of abusive and nefarious use of cloud computing. And many of these risks are unknown. As identified by IDC research in the 2008 year and also in 2010 again, security was and security is the greatest challenge as far as cloud and the success of cloud is concerned, followed by performance and availability. Security comes first, quality of service comes next. So as long as we can assure the customers, the cloud customers, that the services that they are taking over the cloud is safe, the cloud computing business, the cloud computing model as such might not be successful. So the security part has to be somehow balanced with the major goals and benefits that cloud provides us. There are many ways in which any hacker can attack your business through cloud. There are many vectors of attack. The first and foremost being email, web, network, and of course, careless employees of the provider themselves may be a source through which hackers can attack important data. Through these vectors of email, web, and network, there are many means such as spamming your email, phishing your web, hacking your network, SQL injection, and advanced persistent threats are the most important hacker techniques which have been identified recently. Advanced persistent threats. Today's hackers are very advanced in their knowledge, and there is no dearth for their funding. They are very well funded and they are very knowledgeable. And because of this, if they are persistent on attacking any organization or any website or any email, they will ultimately succeed because they are very powerful. So if these are the vectors and these are the means of their attack, how do we as cloud customers, cloud providers, end users, how do we protect ourselves? We need many lines of defense in place. Basically, we need a good antivirus. We need some form of web content filtering, URL, and spam filtering. Our organizations would be using intrusion detection systems, intrusion prevention systems, good firewalls, strong authentication, authorization, and accounting or auditing. So one line of defense would not be sufficing to counter the attacks from today's cloud hackers. If we analyze cloud security, the key issues of trust, multi-tenancy come up. The very fact that cloud is there to share the resources between many tenants. That itself is a cause for lack of trust. Unless this trust is brokeraged well by the providers, and unless the customers can trust a provider that his or her data will be safe, the provider's servers would be safe, the cloud security will remain an issue. There are many issues of whether the data on the cloud is encrypted or not. For example, the data stored on Amazon Web Service, their simple storage services, S3, is not encrypted. It is stored as is. Unless we choose it to be encrypted, data is stored as is. So, if the data is encrypted, the confidentiality issue will be solved. Even if the hackers get access to data, it would be meaningless. It would be scrambled. So, unless encryption is done for all the data, security is an issue. And of course, there are compliance and regulatory issues as far as banks, insurance agencies, and other organizations with sensitive data are concerned. Cloud, by its nature, stores data anywhere in the world. The whole village, the whole world is an iVillage. But compliance and regulatory issues might want to make sure that the data of an organization is within the country or within the campus of the organization. So there are some problems of how the data is stored. On the other side, clouds are hugely complex systems. Beneath the cloud, there are a lot of details which are very difficult to understand from a user's perspective. But the best part is, the user need not understand the implementation details of these complex clouds. Cloud, by its own nature, abstracts these implementation details. How the cloud works, how all these services over the cloud are provided, the user need not know. He only needs to understand how the cloud functions, or rather how he has to use the cloud to get his work done. So, the implementation part is decoupled from the functionality part. The complex cloud, or the way it is implemented, is decoupled from the easy functionality of the cloud. So, the cloud is easy to use but difficult to understand. And the best part is, cloud security is a tractable problem. It's a well-behaved problem. Cloud by its own nature is well-behaved, so cloud testing is easier, cloud auditing is easier. If an organization migrates to cloud, they would find that auditing would be much more easier and convenient compared to the traditional auditing. So, cloud has both its own advantages and challenges. And as former Intel CEO Andy Grove always used to say, only the paranoid survive, and it is very true in today's world of cloud. The general security advantages of the cloud are listed here. As the first point elucidates, when an organization shifts its public data to an external cloud, this in turn reduces its own exposure of its internal sensitive data. The organization itself might not know where its data is stored, but on the other side, the hackers would also not be able to get easy access to the organization's data. This would ensure safety of the organization's data. It is similar to the bank lockers provided by us. We use bank lockers to store our valuables, since storing them in our house would prove to be dangerous in future. So, this is analogous to storing internal data to external cloud. As already discussed, cloud is a homogeneous, well-behaved system, making testing, auditing, and hence security testing and security auditing much more simpler. Cloud does enable automated security management. If security management is enabled, this management could be automated over the cloud, because cloud is a big network, and when we store our data in this network, we could also automate security controls over this network. And whenever a data is stored in the cloud, we could provide redundancy or disaster recovery, which is automated again. The most important challenges would be trusting that the vendor would provide the previous solutions to previous challenges, and also trusting that our data, once it is migrated to cloud, would be safe. And if your organization as a customer has taken some services from some other provider, and you in turn are providing some service to other customers, you might not be able to respond to any audit findings which are related to the services taken by you from your providers. So it is very, very important to sign the service level agreements or SLAs, which are very, very clear. A cloud customer who is also a cloud provider must sign an SLA from his cloud provider to give full support during audit findings. Unless these SLAs are clear and concise, customer might not be able to respond to audit findings properly. These kind of support are required for investigations, and it would be required hugely for making sure that security challenges in a general way would not come in the way of adopting cloud. There would also be indirect administrator accountability for all the services that a cloud provider gives. Of course, proprietary PaaS implementations, platform implementations, and SaaS implementations, software implementations cannot be examined by the nature of these services, which are confidential, which are proprietary in nature. This again poses a huge security challenge. And the most important security challenge would be loss of physical control over any of the services which a customer of cloud is facing. According to the cloud working definitions, 3 types of services would be provided over the cloud: infrastructure, platform, and software. In infrastructure as a service, the cloud customer would not be having any control over the hardware or the hypervisor. He would only be having control over all the software which are deployed over this hardware. The full admin control of the hardware part would be taken up by the cloud provider. So there would be loss of control of the hardware that you are leasing from the cloud provider. When we come to platform as a service, the customer has no control over the hardware or the operating system. He only has limited programmability control over the applications that have been deployed on this hardware and OS. In SaaS, there is almost no control over anything, over the hardware or the operating system or the middleware. The cloud consumer would only be having limited control over the application. For example, if we choose to use Gmail, we cannot change the way Gmail looks or change the way Gmail stores our emails. We can only change how our data is represented, how our username is stored. So as and when we migrate to cloud, the amount of control for a cloud customer would be very, very reduced. This loss of control itself is a great security concern. On one side, we are delegating our responsibilities to a cloud provider. But on other sides, we are also losing control over those matters. So, to tackle such problems, cloud security has to be provided in 5 important phases or 5 important tiers. This would make sure that we are ready from 5 important ways to counter-attack all the security related problems. Let us see the first and foremost component, which is cloud provisioning services. Cloud is a double-edged sword, meaning cloud provides advantages of security. On the other hand, it also faces some challenges of security. In each of the following 5 components, I would be listing the advantages as well as the challenges that cloud has. And we will be looking at what kind of services can be provided in these 5 tiers. By its nature, the provisioning of cloud service is very rapid. It is a very agile technology. Agility is first and foremost benefit of cloud. If a customer of cloud wants to provision a service, he would be able to provision within minutes, as opposed to days or weeks or months in a traditional architecture. Cloud also provides availability and reliability because of multiple data centers or multiple instances available over the cloud for any given service. Also, it would be able to provide very good security by using honeynet capabilities. Honeynets are used to lure or bait hackers and study their behavior in order to make sure that we are prepared for their future attacks. So the provisioning services have a lot of advantages where cloud are concerned. At the same time, something which is too good can also be too risky. Something which happens too fast might also be compromised too fast. There is always the impact of compromising such agile provisioning services. And we always have to be careful to take our time out and to decide properly whether we really want to provision the cloud service or not. Next comes data storage service. This is the second tier. And the advantages of data stored on cloud is that it is not stored in one piece. Data over the cloud is fragmented and dispersed. And these fragments are inter-replicated also. And there is provision of data zones by country for those kind of storage services which by their nature require data of a particular country to be restricted within that region. There is encryption services provided where data is concerned, encryption at rest and encryption while the information is being transmitted between a sender and a receiver. And if any disaster happens, there is scope for automated data retention within the cloud for disaster recovery as well. These are the advantages provided for data over the cloud. At the same time, we face the challenge of managing the isolation of various data which are also replicated, because by its nature there are tenants which are sharing such storage services, and managing isolation in a secure way is a huge challenge. A service customer would not know who is sharing the same server which is storing the data, or who would be able to see the data where the customer is storing. These are huge issues which companies face on a day-to-day basis. Storage controller in a cloud is a single point. Data is stored in a single point and it is sent through the cloud to many users who would be requiring to access those data. Now, if this single point fails or if this single point is compromised, the many users who would be accessing this data would also be facing failure or compromise. This is a huge challenge. And exposure of data of a particular country to other foreign governments is a huge limitation which cloud faces. By their nature, European Union, Canadian government, Japanese government, they have political and government policy which states that data or citizens' information of the country should not leave the country, should not leave the boundaries of the country. So exposure of data to foreign government is not allowed. But by its nature, the cloud does not contain itself within one country or one government. But cloud has to be customized in such cases to hold government data. Next, the infrastructure which processes the cloud. Advantages of such cloud infrastructure is that we are able to secure the master copy, and we only push out the images. We only push out the machine image of any data stored over the cloud. This makes sure that if any change happens to the image which is unauthorized, or if the image itself is lost, the master would be secure. This makes sure that disaster recovery would be safe. At the same time, application multi-tenancy limits the amount of security. There are many customers who would be accessing these images. Through these images, they might be able to get access to the master's copy as well. And cloud always relies on hypervisor. Without a hypervisor, cloud cannot be used. Without a good bandwidth, cloud computing cannot be used properly. Performance will be very bad. Without a good network, without good infrastructure, cloud will not be able to be very successful in performance. We in India, as a developing nation, we face a lot of infrastructure problems as far as network and bandwidth is concerned. Developed countries have very good bandwidth, very good infrastructure, but we as a developing nation, we are not able to leverage the cloud because of our limitations in infrastructure. This could be due to many reasons, one of which is the compliance, which is complacence on the part of our government in giving very high quality, high speed networks. So without hypervisors, without good bandwidth, making use of cloud will be very limited. And isolating such processes through sandboxes is again a very big challenge. This has to be done in a very competitive way to provide very good infrastructure security. Next come cloud support services. Yes, when a service is provided through cloud, there would be additional support services like security controls such as authorization, authentication, login, firewalls, intrusion detection systems, intrusion prevention systems. These would also be provided as support services on demand. The challenges would be, in spite of providing these security controls, we still would be faced with additional risk when these support services are integrated with customer applications. The applications themselves might be insecure over the cloud. So adding these support services might be an overhead again. Now, when such support services like security as a service for any given service on the cloud is provided, we need a certification and accreditation as a separate security application. And there is also a change. There is also a challenge of frequently updating or patching the code for such security controls. If a provider is giving a security software along with his regular service, then the provider also has to frequently update or patch or make sure that his customers are frequently updating their own security software. Until these updates are installed properly, their services which are being accessed might be susceptible for attacks. So it is very important, very important for all cloud services to regularly update their codes so that they are safe from regular attacks. The last but not the least comes the cloud network and perimeter security. As far as the organization's network and security is concerned, the cloud provides very good advantage. By its own nature, cloud is distributed. So it will also be able to provide a denial of service protection in a distributed way. It would be able to install security controls throughout the network, throughout the cloud, and hence be able to prevent DOS attacks or distributed denial of service attacks. It also provides virtual LAN capabilities and perimeter security, which secures the perimeter and network of any organization using intrusion detection system, intrusion prevention system, firewalls, authentication, and so on. The only challenge for perimeter security would be virtual zoning and application mobility. The future trends in cloud and cloud applications are mobile in nature. Future employees of organizations would be working through their mobile devices. They would not be happy sitting on a desktop and working through corporate applications. BYOD is a big concept now. Bring your own device is a concept which will be hugely accepted in future. Gartner predicts that by year 2014, 90% of organizations would allow their employees to bring their own gadgets to access corporate applications and work on their own gadgets. This application mobility provides huge convenience, but it also comes with a lot of security problems. We would not be knowing what kind of applications the employee accesses through its device when he goes back home. This provides huge security implications. So virtual zoning with such application mobility is a challenge over the cloud. These are the 5 tiers of cloud security. These are actually advantages in one way. At the same time, they are challenges as well. So to summarize the advantages, cloud provides the data which is fragmented. It has greater resiliency. It is also cost effective. At the same time, it also has the challenge of managing multiple tenants, of managing isolation, of managing quality of service guarantees. Unless we have hypervisor, unless we have a good bandwidth, unless we provide encryption for all the ways in which cloud services are deployed, cloud would not succeed. There are additional issues of compliance regulatory concerns. There is no one compliance through which cloud provider can provide his services to all organizations. If you want to provide your cloud services to financial organization, you have to be FISMA compliant for financial institutions. If you as a cloud provider would want to provide your cloud to healthcare industries, you have to be HIPAA accredited. PCI for payment card industry, SOX for others to make sure that your data is safe. So there is no one compliance or one regulatory authority which will make sure that your cloud is available for all kinds of organizations. There are many kinds of complaints, so one size of cloud does not fit all, or rather one cloud does not fit all. This is an additional issue as far as security is concerned. So the final conclusion is that we as cloud providers and cloud service users might never be 100% safe from all the threats. If we find some workaround, if we find some solution to the present security problem, another problem might pop up later. There is nothing called 100% security. There would always be some or other loophole through which some or other hacker could target our business. If they are persistent enough, if they are knowledgeable enough, ultimately they might get to us. They might get to our data. So what do we do? As written here, security is not a process. Security is a process, sorry. To make sure that we are updated on the regular security flaws or security trends, there are many industry reports as listed here. RSA has an annual conference on the recent trends of every year, most important security problems. So we might want to update ourselves on the most recent and most important cyber crimes or data breaches or other threat reports to keep ourselves ready. As far as the risks are concerned, the most common mitigation methods used are authentication, authorization, auditing, good SLAs, service level agreements, and monitoring. So if we would want to prevent data loss or data leakage, we would use a good authentication mechanism. If we would want to make sure that our applications are secure, we would design for application security. If we want to make sure that our insiders are not malicious, inside employees are themselves not malicious, we would be using the mitigation method of staff vetting. So there are countermeasures to each and every risk that cloud has known. And this is the reason why the cloud as such would not work if we use a static and one-tiered security. It needs a very dynamic way of managing. It needs a multi-tiered way of managing the security risk. So if we want to secure the cloud in a dynamic and multi-tiered way, the requirements would be authentication, authorization, attribution, audit, and data protection. These were the methods which were being traditionally used. The problems that we had in the traditional business model, the problems are same. The problems have not changed. But the dynamics of cloud computing, by its very nature, changes our approach to these requirements to a multi-tiered protection. One form of such protection is not enough. We need a dynamic way of protecting our data and assets. We need to define which asset is more important, and we need to define how much of authentication, authorization, auditing, and protection is required based on the amount of cost that asset is liable to. If we map such a model to the metal, the cloud model from its IaaS, PaaS, and SaaS, from the bare hardware, middleware, and applications on those operating systems, can be formed into a security control model where The IaaS part consists of the physical, compute and storage, network. The PaaS includes the management of all these underlying different kinds of network, hardware, and the software consisting of applications and data which is stored over IaaS and PaaS. So the security control model has to be tiered in such a way that it is able to counter these attacks on IaaS, PaaS, and SaaS. And the models for this compliance to make sure that a provider is in fact securely providing the services is done by PCI, SOX, GLBA or FISMA and HIPAA. If we map the same cloud to regulations, we find that the cloud workload from the hardware, platform and application part can be monitored or made secure by using tools such as physical security for the hardware, log management and file entry, intrusion detection systems, intrusion prevention systems for the IaaS part. We can use identity and access management, configuring management for the platforms, and for the applications deployed on these infrastructure and platforms, we would be using monitoring, encryption, VPN, and scanners. These would be the security tools used for all these three kinds of services. And the same regulations of PCI, SOX, FISMA, HIPAA would be regulating and making sure that these tools work properly and they work well and the service provider is able to provide the service in a secure and safe manner. So, as a final conclusion, the cloud by its nature is dynamic. So the security for the cloud should be dynamic as well. The most important vectors of attack, the email, web, and file, should be provided safety. We have to define the minimum and maximum amount of security on a dynamic way for every email, web, and file that is stored or that is being transmitted on the cloud. And we have to view it through sourcing, processing and analysis, validation, quality assurance, solution distribution, and solution adoption. This should be done in a plan, built, and run scope so that the customers of the cloud would be having protection and a smart protection for all the problems that cloud presents today, and make sure that they would be able to leverage cloud and the services that come with cloud to improve their business, improve their innovation, and grow through cloud. I thank you all for taking your time out and attending this session on cloud security. And I hope you had some takeaway of why the traditional security methods would not work on cloud. And we would have to work on providing a dynamic and multi-tiered protection over the cloud. I thank you all. And I'll look at the questions now. Now is the question time. So I'll go forward and look for any questions if participants may have. Please type in your questions if you have any.
Thanks for the insightful presentation, Ms. Triveni. Let's quickly take up the questions now. Please read out the questions and their answers so that all our users may listen to the commendable insights. Ms. Triveni, can you see the question panel there? There are a few questions people are asking.
Okay. I see no questions. Just a moment. Okay, what encryption used in this cloud? There's one question here. We could use any encryption. The algorithm has to be dynamic and it has to counter-attack all the problems of the cloud, the provisioning, the infrastructure, and other aspects of the cloud in a dynamic way. The algorithms which were used in the traditional architecture, we would be using the same algorithms, but we will be defining the maximum and minimum amount of security needed, because the cloud itself demands 24/7 monitoring. 24/7 we have to monitor all the resources, all the services provided over the cloud. So by its very nature, we have to be vigilant all the time. So the algorithms have to be dynamic rather than statistic. So I hope that answered one of the questions which asked what is the algorithm used. Basically, it will be a triple AES with minimum of 128-bit key. There is one more question here which asks what is pen testing? Pen testing is basically penetration testing. It is another word used for ethical hacking. So basically, penetration testing is a way to assess the security of a system, of a cloud provider or a cloud customer. Penetration testing includes usage of many tools which test the vulnerability of a service, and it finds what are the loopholes in the cloud service being given and taken. There is another question here by one Mr. Ajay. He asks, what are components needed to cloud computing? Well, I'm not very sure what you asked here. I think you are asking what are the components needed to provide cloud security? If that is your question, the answers lie in the slides themselves. We identified 5 important components through which cloud security needs to be provided. In fact, they are actually the advantages of the cloud. Cloud is a double-edged sword. On one hand, cloud seems to be safe. Cloud seems like a bank locker where we can store our valuables. We can store our data safely because we don't trust our own local storage. But on the other hand, we don't know where the cloud stores our data. So that itself is a risk. So I hope that answered your question. The next question is from Parvati. She asks why physical control in cloud is most important as mentioned by you. Physical control is most important especially for compliance and regulatory issues. If you are a banking institution and an auditor comes to audit or test your cloud, you need to actually show the location of where your data or important services or assets are stored. You need to show the location. And other governmental organizations, by their very nature, they do not allow the data to go out of the country or out of the campus for that matter. So physical control over where your data is stored or how the data is stored is very important. But as we know, cloud by its very nature requires that the customer should trust the provider. The customer should trust the provider that his data will be kept secure irrespective of where it is stored. If we go and ask Google where our mails are stored, Google will not tell us. Google will not tell where its servers are located and how they manage those servers. So we trust Google that our mails are stored somewhere safely. But on the other hand, we lose the control over where our most important data is stored. So physical control is needed when you want your auditing process or testing process to come out successful. The next question comes from Mr. Ajay. He asks, how can we configure cloud system? Well, there are many ways in which clouds can be configured. Do you mean how cloud can be provisioned? If that is what you mean, there are many ways. It is a very flexible system. There is a private cloud, public clouds, hybrid clouds, community clouds. We can configure in any way which we want. But I guess that is not your question. I guess you are asking, how can we configure cloud in a secure way? How can we provide these multi-tiered security services over the cloud? Yes, we can. Along with the services that we provide as SaaS, PaaS, or IaaS, we will be providing security as a service. Any service that goes out from the provider to the customer as an infrastructure, as platform, or as a software, we would be sending that service out with this additional security controls. This is how we will configure the cloud. For example, infrastructure as a service can itself come in two ways. Infrastructure software as a service, infrastructure hardware as a service. If you consider infrastructure software as a service, we would be configuring the hardware devices that many people would be accessing in future in BYOD. Employees of future would be taking their own gadgets to work, and these gadgets would be pre-configured. These gadgets would be installed through the hardware itself. A software will be installed. It is called infrastructure software as a service, in such a way that their devices will be secure and it will be hacker proof. That is one way in which we can configure the devices which will come out in future, which employees can use for accessing corporate applications, for doing their day-to-day work. There is one more question here. If encrypted, how can one government data available to another government is mentioned as a threat in data storage? Well, encryption is not enough as a secure means. Just encrypting data is not a foolproof method. There are advanced hackers who are able to decrypt the encrypted data. There are language pundits who would be analyzing your data. They would be having statistical analysis means through which they are able to find some patterns which the plain text or the regular data which was there, some patterns of that normal plain text would survive in the scrambled data. They would be able to analyze that pattern and they would be able to come out with the plain text. So only encryption would not be a safe means to make sure that other governments will not understand if they get the scrambled or encrypted data. So we need other means of safety also. First and foremost, we have to make sure they do not get hold of data. I hope that answers your question. Only encryption is not enough. One more question by Mr. Arun. User level privacy, can it be always assured? Well, as I have told in the previous webinar, there is nothing called 100% security. But we can be prepared to our level best if we know what are the most frequent on most common mistakes made by a general population. We have to make sure that our passwords are safe. Our passwords must not reflect anything which is known to us. Our relatives, our favorite hobby, our friend's name, all these must not be our password. It should be something very random and very unconnected to you. Most common mistakes people make in accessing any kinds of services, be it email, be it LinkedIn or any other social media, is how they choose their password. So password should not be related to you in any way. It has to be random and unpredictable. So by eliminating such common mistakes, you can be prepared to an extent. You can be prepared that your user level privacy is protected. But it cannot be always assured. Like I told you, today's hackers are very advanced. They are very persistent. And if anyone can put their mind and heart, ultimately they will be able to get what they are after. So we have to be safe. Know thyself is very important. We have to know what our weaknesses are, and we have to be prepared best to make sure others will not use their weaknesses. First and foremost weakness over the internet is our password. We have to make sure they are safe and secure. Always use a password that has no connection to you. And of course, on a day-to-day basis, Facebook, LinkedIn, and other social media, the way we are using them can also lead hackers to get a lot of information about us. So unless otherwise needed, our name, date of birth, email ID, and phone number, they give out a lot of information about you. Your personally identifiable information should not be given in one place unless otherwise needed. You need not display all your information on LinkedIn or Facebook unless otherwise it is needed. So these are the ways through which we can maintain our user level privacy by eliminating the most common mistakes people make. What do you mean by virtual zoning? Well, virtual zoning is basically a way by which all data stored on the cloud is zoned into many different zones. We make sure that the many different copies of any data, which is actually fragmented. Data is fragmented, and again those fragments are redundant. They are made as copies. All these have to be virtually zoned, virtually made separate in such a way that many tenants who are sharing data will not be able to access each other's data. Cloud by its nature is virtual. So such virtual data have to be zoned very safely in such a way that they are isolated. So basically, virtual zoning means isolating the different copies of different customers who are using the cloud. One question by Mr. Suresh. Can you please brief about cloud computing? Well, TechGig has organized many webinars on cloud computing. This series is all about cloud security. Since my webinar was about cloud security, I started off directly with the advantages and disadvantages of cloud. I did not introduce the cloud as such. But yes, if you would want me to brief about cloud, I could brief it in one word, one sentence, one para, or I could go on for the next 2-3 days talking about cloud. But yes, the best briefing about the cloud would be the NIST definition. The NIST definition of the cloud states that cloud is a convenient, on-demand resource which are pooled by many users in such a way that there is minimum interaction between the users and the providers of the cloud. So cloud by its own nature is defined in such a way that all the 5 important properties of the cloud comes out within its definition. NIST definition, or the definition from National Institute of Security and Standards, which says cloud has 5 important characteristics, the most important being on-demand self-service, which means that whenever anyone wants, anyone can access any service as long as they are connected to internet. It has ubiquitous network access, meaning anywhere in the world, through any device, you can access anywhere, anytime. Rapid elasticity, meaning the services given over the cloud are very elastic and flexible in nature. If you want the cloud today, you can take as much servers, storage, or other network resources you want, and tomorrow you can leave all that. You can give all that back with no loss. Location independent resource pooling, yes, the basic way in which cloud services are given are in a shared way. Because many users are sharing the cloud is very cheap, it is very cost effective. The more the users are sharing the cloud, the more the cost is reduced. Last and not the least, measured service. Cloud is always given in a pay-per-use basis. Pay as you go, or rather pay as you grow. If you start your institution now, in future your usage for servers, storage, and other network facilities might grow. So as you grow, you might want more and more such resources. And these can in turn be provided in a measured way. You would not be underestimating or overestimating your services required. So these are the 5 essential characteristics of the cloud, and this is the NIST definition of the cloud. I hope that answers your question. How can we ensure that our data is safe in cloud? One Mr. Ganesh asks, as has already been discussed, one way is to choose our data to be encrypted before storing in cloud, and to make sure that 3 A's of authentication, authorization, and auditing are in place. By making sure that our passwords are strong, by making sure that along with using password, we also use biometric protection. We also use good authorization and auditing mechanisms. We can make sure data is safe in the cloud. Which banks in India are using cloud computing technology? This is a very good question. Recently, I had given a 2-day cloud computing course for Deutsche Bank, but unfortunately, not many organizations, not many banks, especially in our country, are using cloud computing. They are still watching. They are still watching, and they are having a wait and see kind of strategy, wherein they want to see how others are adopting this technology, how it is faring for them as such. They are very much aware of the risks that cloud is bringing with it. So they are hesitant as of now to go into cloud. So if you want an answer to your question, which banks in India are using? Well, it's a disappointing none as of now. None that I know of, at least. One more question here. I guess this would be the last. It's already 4:10. So if you can mail me the remaining questions, I would be glad to reply you with the answers. I will answer one more question by Fateh Ahmed. Can you please let us know that what are some of the best ways of observing hackers' behavior? Well, the most important method to observe hackers has been sandboxing, honey nets, wherein some bait is created only for hackers. We observe hackers and we observe through which links and through which plugins they actually try to attack a network, and we create a bait through our portals or websites, and we make hackers think that they've actually come into and got hold of some of the resources into the websites of any organizations that they're trying to attack. Once they are convinced that they have got through the website and they have got through the data of the website, they try to take some information. They try to go around the portal and they try to see what is around. But the particular application through which they are attacking us, we try to sandbox it. We try to put it into a sterile, non-executable environment, and we try to actually observe what they do and for how long they are doing it. What exactly are they looking for? Are they looking for employee login? Are they looking for employee email details? Are they looking for credit card information? Or are they looking for some important information regarding the institution? So these observations give us a very good insight into how to protect ourselves in the future. So sandboxing and honey nets are very good ways to observe the hacker's behavior. Yes, there is a right way to do it and there is a wrong way as well. Right way to do is it, bait them, sandbox them, observe them and let them go. But yes, some other organizations are also doing it the wrong way. They bait the hackers, they make the hackers actually take some of the important data of the organization, they catch the hackers red-handed and then they sue the hackers. They make them go to jail. But this is the wrong way because you yourself have provoked or baited the hackers, you made them do the wrong thing and you caught them. So this is the wrong way. There is also the right way. But according to the policy now, the wrong way is the right way because that enables us to keep our data secure. Yes, our thoughts on security have changed. Our methods to secure ourselves have changed because the knowledge of hackers have increased a lot, but our knowledge about them is going on decreasing. I hope this answers your question. So we shall stop the question and answer session here. I would be able to reply to the other questions through mail. Please feel free to mail me for any of your concerns or questions or doubts related to security, cloud security. I'd be happy to answer them.
I'm really thankful to our guest speaker, Ms. Triveni, for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgeek.com by tomorrow. Thank you all.